Hi, good morning, everyone, and a very warm welcome to Heavy Clay Online 2025. It's brilliant to have you all with us, whether you're joining from your office, your kitchen, quarry cabin. If it is the latter, don't worry, it's being recorded when inevitably your internet packs in. For those who don't know me, I'm Imogen Harding, currently the interim chair of the Heavy Clay Technology Association. It's a real privilege to be at today's event and to open what promises to be a really informative, practical and relevant set of talks. Before we get stuck in, I just want to take a moment to acknowledge someone who's been absolutely instrumental in shaping the HCTA in recent years, our outgoing chair, Paula Wardle. Many of you will know Paula personally or through her work, and you'll know the energy, dedication and commitment she brought to the role. She championed best practice, encouraged collaboration and helped keep the heavy clay sector moving forward during some really challenging and fast-changing times. On behalf of the entire organisation, and I'm sure all of you joining us today, I just want to say a really huge thank you to Paula for everything she did for the industry and for this organisation. Well, on to today, our speakers. We've got three really excellent sessions lined up, each bringing something different and genuinely useful to anyone involved in quarrying, geology, materials development or manufacturing. First up, we've got Professor Andy Smith, who is Head of Materials Development at Forterra Building Products Limited. He's also an Associate Professor in Mineral Products Technology at the University of Derby. And if that wasn't enough, he also chairs the European Standards Technical Committee for Masonry Products. His talk today has a brilliantly memorable title, Just Throw the Kitchen Sink at It. Judicious, easy for me to say, use of analytical tools to solve material-based investigations. If you've ever been faced with a stubborn clay, an uncooperative raw material, or a mysterious defect that refuses to explain itself, you'll know how tempting it is to literally, or metaphorically, throw the kitchen sink at the problem. Andy's going to take us through a huge range of analytical techniques available, from simple in-house tests to high-tech specialist tools, and show us how to interpret the results and actually put them to use. It's going to be practical, thought-provoking, and packed with real insights into how we can make better decisions about the materials we rely on. Following that, we're joined by Brian Duffy, who's contributing to the Heavy Clay Online event with a session that dives straight into the real, on-the-ground challenges our industry is grappling with when it comes to geotechnical work in quarries. Brian will be reviewing a whole range of current issues, HSE interventions, RIDDOR trends, and the critical importance of selecting the right specialists for geotechnical tasks. On top of that, he'll be talking about the work of the Quinjac Geotechnical Subcommittee, which I know many of you know are doing an enormous amount to support safe and compliant quarry operations across the UK. If there's one thing we can all agree on, it's that geotechnical hazards don't politely wait until we're ready to deal with them. Brian's perspective on what's happening right now, where risks are changing, and what we can do about it is going to be hugely valuable. Please have questions ready for him, because this session is a great chance to get clarity and insight for someone who really understands the current landscape. Rounding out the programme today is Rob Lauder, who's another exceptional addition to our lineup. Rob will be presenting his talk on drones, monitoring excavations and stockpiles. And if you've ever tried to keep up-to-date records of excavation progress or attempted to capture the true condition of a stockpile without sinking into it, this session is absolutely for you. Rob's the company geologist for Wienerberger UK, covering all their sites with a special focus on clay quarries. He brings a brilliant blend of practical experience and academic grounding with a BSc in Exploration and Resource Geology and a postgraduate certificate in Remote Sensing and GIS. What really stands out about Rob and this talk is a personal passion for drone technology. He's not using it to tick a box, he's genuinely exploring how drones can reshape the way we document, monitor and understand our quarry sites. Today, he'll be showing how drone surveys can track excavation progress, assess stockpiles, and produce high-resolution visual records of site geology and condition, all without needing anyone to put themselves in a precarious position with a compass. It's one of those areas where technology is moving fast, and Rob's talk is a great opportunity to see where things are heading, what's possible now, and how we can apply it in day-to-day in heavy clay operations. So we've got a fantastic programme ahead of us. Analytical tools and material investigations with Andy, geotechnical realities and safety trends with Brian, and drone-based site monitoring with Rob. Three experts, three very different perspectives, and a whole lot of useful knowledge to take back to your teams, your sites, and your projects. After the three presentations, we have the Student Awards, along with the Keith F.R. Morton and Ernest Simpson and Lisney Prizes. A great moment to recognise those who work among us. Before we begin, I just want to take time to thank you all for joining us. Heavy Clay Online is only ever as strong as the people who take part. And the fact that so many of you keep showing up year after year is a proof of just how committed this industry is to learning, sharing, and improving together. Thank you also to everyone behind the scenes who's put this event together. These things don't run themselves, and despite how effortless it looks, hopefully, when we're all logged in and underway. Chris and Steve from the HCTA, alongside Paul Redfern from Lingle, and also Isaac, Louise, and James from the IQ. Right, as always, that's enough from me. Let's get started. Thank you.
Hi, and thank you for joining me for this presentation on Just Throw the Kitchen Sink at It. Most of you all know me. My name is Dr. Andrew Smith, Head of Materials at Forterra Building Materials. Some of you will also be aware that I'm also one of the main deliverers of the programs at the University of Derby on the play side of matters, and also that I also chair the European Standards Technical Committee for masonry products. So as you can imagine, analytical techniques and how to solve minerals-based problems is very close to my heart. So let's start off. Let's try and put things into context. There is a great importance in understanding what analytical techniques are available and how we can use them. But the first thing that sprung to my mind was you can have all the gear but no idea. And in the sense that what I mean there is that you can have all of the equipment at your fingertips, which these days we predominantly do. But if you don't have the idea of how to use them, then you're defeating the object. You may be making mistakes, you may be making some misinterpretations that can lead you down paths that you don't necessarily wish to go. So the analytical toolbox, this is what I would say, this is where the magic really happens. Well, it really only happens if we use the right tools for the right job. So a lot of this presentation today is really around understanding really what you're trying to achieve in the first place. So a lot of the hard work is done before you actually go out and use the analytical techniques. And by understanding and scoping what I would say is the question. So it's all about the question. So really it's what information are you trying to acquire? You can put that in another sort of way, which is what are you trying to understand from the questions that you're asking? What is the problem you're trying to solve? So really, before we throw time, resource, and money into solving a material-based problem, we need to understand the fundamentals of what that problem is and putting it into a context that allows us to pick the right tool for the right job. So I can sort of break that down then into well, what is it, where is it, when is it, how is it, and why? So the what aspect of that is very much around the scope. What is the type of information that you're requiring from an analytical investigation? And in the context of heavy clay, then a lot of the time that is relating to the materials that we're using. So predominantly things like the materials in the ground that we're all winning ourselves, or those materials that we're bringing in from external third parties. The where could be somewhere in the sense of, is it a specific material? So is it a particular quarry? Is it a particular seam within a quarry? Or is it more generic? Or is it also specific to a stage in the manufacturing process? And by understanding this where concept, then that allows us again to focus on what are the tools that will give us the best opportunity to understand and give us answers to the questions that are being asked of us. The when is also important because we could be looking at something that is a continuous understanding of material. So let's say it's a longer time frame sort of investigation. And this could be something relating to, let's say, a new quarry extension. So we need to have a number of basic bits of information that we can use for the next 5, 10, 15 years as that quarry is developed and worked through. It could be sporadic. So a lot of the analytical resources that I'm asked to look at are things that are unusual. So something happens in the process, an unusual reaction takes place, the wrong color, the bricks start to bloat, something like that. And it's something that's here today but gone tomorrow. So what is it that potentially could have caused that problem? Are we doing effectively a forensic investigation of a failure in some of the material that we've been using that we can then go back and have a look at in a little bit more detail? Or it could be something very specific. So it could be something as specific as it's an ongoing problem, but it has a specific start point and potentially a specific end point. So for example, let's just take the example of a sand stain. You know, if the formulation for the sand stain is not quite right, and therefore we get a different color than what we were expecting coming out of the kiln, what can we do? What tools can we use to investigate why that has happened? And it may not necessarily just be the material itself. It could be the kiln atmosphere, it could be the firing temperature, or it could be something else, a contaminant, for example. And finally, the how. And this is actually really important, is to understand the problem in the context of why it has been identified as a problem. So it's how the process is being impacted. So those are the sort of the what, the where, the when, and the how. But fundamentally, we're trying to answer the question, well, why has this happened? So what analytical tools can we deploy to answer the why part of the question? Well, it's not just the analytical results. So it's not just picking the right tool. It's not just getting the results. The most important thing here is that the results are meaningless unless we can interpret them. And by interpreting them, we have to put them back into the context that the question was being asked in the first place. And what I would say is the beyond why component of that. So we can give the answer, we can identify, or we can give the interpretation, but more often than not, where us within the technical field, within our businesses, really earn our crust is we can give recommendations. We can identify whether or not this is transient, this is something that's likely to happen. Now, fundamentally, a brickworks manager, what they really want is consistent raw materials so they can set up the factory to run consistently and everybody will be happening. We're effectively just cranking the handle and the same product comes out with no deviation or derivation from what we're expecting. The challenging thing comes is when none of that comes together and everything is changing. We need to be able to identify what there is in terms of things that have changed, why they've changed, and what we can do to get things back on an even keel and actually get them back to standard production criteria. So let's have a look at the what and the where. So I'm sure a lot of you will be very familiar with the type of investigations we do, such as quarry face sampling or borehole investigations, or for that matter, sampling from deliveries that take place where we're getting materials from third parties. And the where, so it could be in the quarry, it could be in a green field that we're investigating where we're getting the boreholes, the core samples like you can see in the picture on the left there. Or it could be something more specific and closer to home in terms of it could be in the stockpiles that we've built We could be taking material out during the preparation stage, the forming stage, the drying stage, or the firing stage of the actual brick making, roof tile making, clay pipe, clay paver type process. So there's an aspect here of, again, depending upon where you are in the process, if you're right at the very front end, before the material has actually ever been won, or you're within the process and something is not quite right and you're being asked to investigate it, then there are different tools that you would apply or deploy in order to give you the answers that you're looking for. So this is a rather busy slide here, but it shows you, I suppose, a snapshot of what I would consider to be in my analytical toolbox. And I've broken it down, as you can see, against properties, things like the particle size, the mineralogy, the chemistry, running from left to right. And then running up and down on the left-hand side of the screen there, you can see that I've broken it down in, are we looking at exploration evaluation, this part of the process? So we're looking at potentially borehole samples or quarry face samples, potentially even looking at the stockpiles once we've built them. Are we looking within the production process itself? So within clay prep, the forming, the drying, the firing, as I mentioned before. Or are we looking at something that is on the tangent or on the periphery, rather, of what we do on a day-to-day basis in the manufacturing process? So are we looking at something relating to environmental or the sustainability criteria? Or are we looking at something like exotics or the contamination side of things? And I've just color coded these. I went through and looked at these and sort of said, what are the tools that I would commonly look at? What are the less common ones that I would look at, and what are the ones that I'd rarely use for a particular investigation? So you can color coded green, orange, and sort of grayed out here. So in a sense, this is a bit of a snapshot of what's in the toolbox. The important thing is to understand what is the right tool to answer the right, or to give you information that allow you to answer the right, or give you the right answer that you can then go on and do the interpretation for and give the recommendations for. So it's not only about just having the ability to go send a sample off or do the testing yourself. It's really about what will that answer give me that I don't know currently. And that's the important thing. That's where we earn our crust as far as the business is concerned. We can put back into the business some rationale, some evidence that says this is happening because of this. So let's have a look at understanding clay-based materials. And because we're talking about heavy clays here, and we're talking about the heavy clay side of the construction materials sector, all of these are pretty much applicable to any of the heavy clay product types. Obviously, I'll be focusing on bricks, but it's applicable to block, it's applicable to roof tile and pipe manufacturing as well. So size matters. Sorry, gents, I have to say that this, but in the context of particle size distribution, size really does matter, because we think of our deposits as being clay deposits. We talk about them being clay deposits. But as those of you that will have done this type of analysis before, you will know that essentially the clay mineral component can be as little as 10-15% of actually what the bulk raw material is in terms of what we make our clay bricks, our roof tiles, our clay blocks out of. So understanding actually the fundamentals of how much clay is there in our clay deposit is actually really important. And fundamentally, it breaks down to essentially the sedimentary deposits that we are looking at, the raw materials we are looking at. We can break them down into 3 or 4 principal size fractions. We can look at the clay fraction, the silt, the coarse silt, and the sand fraction. The bit we're really interested in is the clay fraction and also the silt fraction. The coarse silts and the sands, they are basically the bulking agents that go in there that can change some of the properties of the raw material as it goes through our manufacturing process. But fundamentally, the first thing we need to understand is how much clay we've got present, because that then leads on to other aspects that will give us an indication of how the clay is going to perform. So the more clay we have, that will affect the plasticity properties. So that will have an influence on the shaping, the forming process, as well as the drying process. It will also have an influence upon the firing process, because the more clay mineral we have, the more ceramic glass we're likely to produce that will bond the brick together and fundamentally give it the physical properties at the end of the firing process. So right up front, by understanding how much clay mineral we have present, we can start to answer some questions with regards to how the final product will perform. And this can be done in a number of ways, but you can see here, these are what we call ternary plots. So you can see in a triangular form here, so we have each of the points of the triangles represents sand, silt or clay fractions, or in the case of the Winkler diagram that you can see here, we've got clay, silt and coarse silt being plotted. On the right hand side, what you can see here is a piece of work that was done in Germany a number of years ago that identifies areas within this plot that are important and give you an indication of what a raw material is best suited for, or rather it's actually reflecting what the majority of product being made out of a particular deposit is being used for. But it gives us some insight into the subtleties between the clay and the silt ratios and how that will influence the types of product that we can easily make out of the clay deposit that we have, and whether or not we need to modify it. So those areas there, you can see there are materials that are better suited to roof tiles, vertical perforated bricks and solid bricks. And the influence there is it moves more away from the coarse silt fraction and swings up towards the clay fraction. The reason being, roof tiles are fairly narrow, thin-bodied, heavy clay products, and to extrude those, essentially the material needs to be more plastic than what we need in terms of solid bricks or perforated bricks. So these sorts of criteria are important for us to get a handle on in the first instance, but we can take that forward. So particle size really matters. We can look at it in a number of different ways. There are tools that are out there. We can go as basic as looking at a mason jar, the soil test. We can put some of our raw material in a jar, shake it up and let it settle. That will give us, based on sedimentary process, that will give us a sand, silt and clay fraction in a sequence that we can actually look at the side of the jar. Or we can use analytical techniques to do it. So we can look at something like the Malvern Mastersizer, which is a laser sizing process, or we can use something like a Sedigraph, which uses a slightly different technique. But essentially, we can use the same approach to understand. So one of the things is we can get data that is presented in a number of different ways. So I've just put two graphs on there that show exactly the same data, but they're presented in two slightly different ways. So one is a standard grading curve, one is a volume density percentage. And depending upon what questions you're asking or what answers you require, you can use both of those techniques to basically present the data in the way that's best or easiest to interpret. So if we take the data from what we can see here, and if we take the upper one there, which is our standard grading curve, we can then take that information off and we can say, okay, well, what is our clay fraction? What is our silt fraction? What is our coarse silt fraction? And where does it plot on our clay, silt, sand graph. And so the material I was looking at here plots in this silty loam area, which is not untypical of the types of material that we generally use for making bricks out of. Plasticity, so the clay influence on the way that the clay body performs, is also important. So clay's superpower number one is its plasticity. So I'm sure we all recognize the things like we've got non-sticky, so material that actually doesn't stick to your fingers as you play with it. It can go through to being very sticky or very plastic. But occasionally it can be a little bit over there, so we don't really want to go there. So how can we look at this plasticity process? We can use something like the Casagrande method, which you see here on the left. This is a method for determining the liquid limit. So the point at which our clay body performs more like a liquid than a solid. And then the second aspect of this is we can look at the plastic limit. So there's a Casagrande method where we can use the equipment there with the brass shell. It's an old technique that was developed for assessing soils and geotechnical information for soils, but it's really useful in understanding where the thresholds are for how much moisture you need to make a plastic body. So what the upper limit is and what the lower limit is. The plastic limit at the opposite end is how little moisture you can get away with putting into the body. And this is really the area that we need to be working towards, that threshold. So we need to have a plastic body so we can mold it and shape it, but we don't want too much water in there that it's going to take us a long time to dry the products during the drying process. So we need to be able to form the brick shape, the roof tile shape, extrude the clay block. But we don't want it so wet that it takes us a long time and a lot of energy to actually get that water out of the body. So using this plasticity index, we can get some predictive understanding of how our material is going to perform. And we can use this. It's key to understanding the extrusion, the soft mud, the drying shrinkage, drying sensitivities. And then we can use that information. So for each clay type, we can identify what the optimum is for the particular processes that we're trying to look at. So if you're using it for soft mud or if you're using it for extrusion, they will have a different plasticity index value that you're trying to achieve. So it's quite a powerful tool in terms of understanding how your clay is going to perform during the manufacturing process itself. So let's have a quick look at mineralogy. Mineralogy I would describe as it's the clay sandwich. So these are sheet silicates. So sheet silicates, by the name, the sheet implicates that what we're dealing with is layered systems here. So clay mineral structure, you can either look at it as an open sandwich, a standard sandwich, or a club sandwich. So just going through the 4 clay mineral groups. So we've got kaolinite, we've got illite, we've got our mumbrillonite group, and then we've got a chlorite group. And these are our basic clay minerals that give us the clay plastic properties of our deposits. And they can be all present or they can be present in different proportions. But the important thing is that we understand what clay minerals are present because they have fundamental influences upon how our clay material is going to perform, particularly in the plastic state. And the club sandwich there, I'll just put a gherkin on just for your benefit. So it's all about the sequencing, so the structural sequencing of the clay mineral, and what sits in between the layers of the sandwich gives us an indication of how that's going to perform, particularly when the interaction with water. So one way we can look at the clay mineral in specific is we can extract the clay mineral from our clay body, and we can look at it in terms of how it reacts. And one of the important things is using a technique known as an X-ray diffraction, and particularly the clay-oriented mount process. So basically, we take the clay off as a slurry, we pipette it onto a glass slide, we dry that glass slide, and then we run it through an X-ray diffraction machine. And this allows us to differentiate. Clay minerals have very, very similar structures. So one of the important things is for us to be able to differentiate between the clay minerals. So we can use an air dried, and we can treat the sample with ethylene glycol as well, which expands the spacing between. So it works on the swelling clays such as the montmorillonites. Or we could heat treat them, such as the kaolinite, where if you heat kaolin to above 550 degrees, the structure collapses, so it disappears off the trace. On the montmorillonite side, if we use ethylene glycol to soak into the clay, then what it will do is it will expand the layers, the swelling layers in between the clay structure, and therefore we can see that with the X-ray diffractometer. Again, if we then heat it, they will collapse back to the elliptic structure at 10 angstroms. So there are lots of these different techniques, and there's a lot of interpretation that goes with it, but they're powerful tools to understand and predict how our materials are going to perform. And this is just one way of one material that we've looked at, basically air dried and glycolated, and we can see that there is a montmorillonite or a smectite type of clay mineral present that is going to influence the drying shrinkage, the plasticity values for our material as we use it. The other thing we can use is what happens during the firing process. So understanding what happens in terms of to our clay body as it goes through the firing process. And essentially what I refer to this as is, and some of you all heard me talk about this before, is the time temperature transformations. And we can use X-ray diffraction to actually give us that. An indication of what is happening at any given time, such that on the right hand side of the screen there, we can sort of give a cartoon to say, this is what the minerals, each of the minerals is doing at any stage during the firing process. So the ones for us that are really important is, what are the clay minerals doing, and what are some of the other materials doing, such as the calcite, the gypsum, the pyrite, because they're the ones that will be giving off gases. The illite, the chlorite, the kaolinite, the montmorillonite, they will be converting into the ceramic glue that sticks our bricks together. So finally, let's touch on a few aspects of chemistry. X-ray fluorescence, it's a widely used technique. Major element oxides, so we're looking at things like the silica content, the alumina content, but what can it tell us? Well, here's two examples. We've got two different materials here, and it's a case of picking the bones out of it. Don't panic if you're not a chemist, because you don't actually need to be a chemist to understand some of the aspects, the things that you might be wanting to look for. So for example, the first things, the alumina and the silica. This gives you an indication of, roughly speaking, how the alumina value gives you an indication of how much clay mineral is present. The silica tagged, the ratios are roughly proportional for each of the clay minerals. So you can tell roughly how much clay mineral you've got there and how much quartz you've got in there, so how much sandy material you've got in there as well. So the alumina and the silica, first place to look at, two different aspects here. Next one, obviously a lot of us are very much dependent upon what the color of our product is, so therefore the iron content is important. Looking at the iron content gives us an indication what color it will fire to. We can also look at things like the potassium, the magnesium and the calcium. These are some of our fluxing materials. So calcium and magnesium often are either associated with certain types of clay mineral, the smectites, the montmorillonite group, but they can also be associated with the carbonates. So the other thing to look for down the bottom there is the carbon content. A high carbon content normally means you've got organic carbon in the sense that you've got a fuel material in the material as well, or you've potentially got carbonates present, and therefore you get CO2 emissions. So we can have a look here just at some examples of the variation from coal measure shales down to the brick earths and the galts and the wheeled clays, variations on the raw material chemistries. So you can go back, you can look at these, you can routinely check them, see if anything is standing out as being different. So it can be used as a general screening tool. We can also use it to see, for example, we can look at the fluxes. So therefore, what temperature things are likely to happen. So if we have high potassium, high sodium levels, things are likely to happen at a lower temperature in terms of glass formation, the ceramic bond in the firing process, than if we've got calcium and magnesium dominant materials. And therefore we can use those, we can plot those, we can use that information in a slightly different way to give us an indication of where our materials fit. And finally, thermal analysis. So we can look at things like differential thermal analysis, DTA, thermogravimetric analysis. So again, we're looking at reactions that take place, both mineral and chemical, during the firing process. So we can look at energy consumption and what happens when reactions take place. We can also look at weight loss. So when water is lost, when the hydroxyl ion is lost, or when gases are evolved, because that will result in a weight loss in the process. So the green line here is weight loss through the firing process. That weight loss can also be associated with shrinkage. The DTA aspect gives us some of the mineral reactions that are also taking place. And finally, evolved gas analysis. It's important we understand that this is an environmental impact, because a lot of the gases that are evolved during the firing process from our raw materials end up going up the chimney. But we can look at these in a bit more detail. At what temperature these things will happen? When is carbon being burnt out from our clay? Therefore, do we need a carbon burnout dwell in our firing curve to make sure we don't bloat the bricks, like the example you can see there on the left-hand side? So this tool is quite useful in understanding what gases are coming off at what temperatures, and therefore we can build that into our firing curves. So that's been a little bit of a rapid run through the analytical techniques or the approaches that you can use. So the judicious use of analytical tools is basically select the right tool for the right job. So with that, I'd like to thank you. I hope you found that useful. It's a little bit of a skip through the process, but hopefully that will give you a few insights of what can be done and how you can take that information and put it into your manufacturing process. Thank you.
I thought that was really interesting, especially the bits about making sure the right tool is being chosen and really thinking about why we're using that analytical tool. If there's any questions, if you've got access to the Q&A chat box, you can put them in there and they can be answered. If no others, we'll move on to Brian Duthie. Thank you very much.
Good morning. I just want to do a bit of a quick run through on some geotechnical issues facing the industry. 25 years into the quarry regulations, and we still seem to be having major issues with geotechnical, and it's always remains under the spotlight of the HSE. I'm a geotechnical specialist, approximately 35 years experience working across many different types of geological conditions, both in the UK and overseas. I was part of the original consultation committee for the quarry regulations when they were being written. I want to talk about HSE major interventions, not necessarily what they're looking for, but what they've been finding in the ones that they've undertaken. I know that the bigger brick manufacturers have all had major hazard interventions, and I've had some feedback on those. Plus, as well, what they've been looking for across the aggregates side of things in quarries. Talk briefly about a couple of things, bits of guidance that the Quinjac Geotechnical Subcommittee have produced in recent years that may be of help, particularly the geotechnical self-audit. And then I don't know if this works on Teams, but I was really looking with the last part to open it up to the floor and get people's views on geotechnical riddles and when we should be reporting and not. So on the HSE major hazard intervention, so the HSE have identified a number of areas, specific areas where they want to undertake major interventions, major hazard interventions. The two main ones are geotechnical and blasting. They're also looking at RCS. I'm just going to concentrate on geotechnical today. So the way they've been doing it for multi-site operators, as they now call it, they've been giving 2 to 4 weeks notice of their visit and been asking for documentation in advance. The idea being that they're able to review all of your geotechnical documentation before they come to site and hopefully make things a bit smoother on the day. For smaller operators, they've been turning up unannounced to do these interventions. They don't necessarily seem to have been consistent, because I know, speaking to some people, that they have had the notice and other multi-site operators haven't necessarily had the notice. And I do believe there are some people in the audience today who have had the pleasure of one of these interventions. So the things that they're asking for in advance or to see on the day, everything associated with Part 6 of the Quarry Regulations, so your excavation tips rules, and any associated safe systems of work that you might have. So, for example, job cards that a lot of companies use nowadays. They're looking for your inspections, so your Regulation 12 inspections in relation to your excavations and tips. Copies of any Regulation 32 appraisals that you might have. Copy of your latest, well, in fact, the copies of the last 2 geotechnical assessments. So your most current one and the previous one. I think they're really looking there to see that you have undertaken the recommendations given in, for example, the 2023 one, to make sure you're not getting the same recommendations in your 2025 assessment. Looking for your quarry designs and also evidence of employees' competence, particularly those who've got work that they do in relation to excavations and tips. So some of the things that they've been finding across all of quarries, not just within heavy clay, there are certain themes. Insufficient evidence of 8.1c and 8.1d competencies. Not to say that the people are not competent to do the job, but it's the evidence that they have had the appropriate training and the appropriate levels of experience, and the companies haven't been able to necessarily provide that. The site health and safety management structure hasn't always been up to date or been present. So the organogram that shows whose responsibilities are what within the organisation. Lack of evidence. We've had a couple of these ourselves where the operator hasn't been able to provide evidence of notification of significant hazards. So the HSE have got a list, a database of all the significant hazards that have been notified to them, and they are asking for evidence that you have notified the HSE of any significant hazards on your site, and we have had to go back and retrospectively notify a number of significant hazards. I know some operators in recent times, particularly in the aggregate side, they have had their own databases and have basically just forwarded that database to the HSE to make sure that they are covered in regard to notification of significant hazards. They have found evidence that the quarry is not being operated in accordance with the quarry design. So that's not to say that they were operating it unsafely, but if you do go to the expense of having a quarry design produced and put on paper, then make sure that you are going to operate in accordance with it, or get the quarry design updated, revised to reflect what is actually going on within the site. And then there have been discrepancies between the geotechnical assessment, the quarry designs, and the excavation tips rules. So one prime example of this that they have found on multiple sites is where the face angle specified in the geotechnical design, in the geotechnical assessment, sorry, are not reflected within the quarry design. And not necessarily reflected in the excavations and tips rules. This happened quite a lot, it would seem, within the aggregates side of things, and particularly where the blasting of the faces, blasting of hard rock faces is involved, and they have been picking up that the blasting isn't necessarily trying to produce the face angles that have been specified in the geotechnical assessment. And there have been a number of investigations in relation to instability within sites where that has been flagged up, that there has been a discrepancy between the drilling angle and the what's specified in the geotechnical assessment. Not being able to provide evidence of all features having a design. So quite often this may be that there's a new excavation and tip feature that's appeared in the quarry because it's been necessary to build a new ramp or build a new tip, and they haven't been able to provide evidence of a design. So make sure that all of your excavation and tip features
let
do
me
have a
check.
design.
I just came on now. With old one. So
Oh, is he muted now? And this one is, again, it's across all types of quarries. Quite often there's been no record of the relevant parts of the documentation having been communicated to all personnel, including contractors who have responsibility to abide by them in relation to excavations and tips. So this may be that proof that they have been given the excavation and tips rules, and they have had the excavation and tips rules explained to them. At the end of the day, the excavations and tips rules are the key document in the operation of the quarry, and the guys on the ground, whether it be your own personnel or contractors, they do need to understand the excavation and tips rules, and everybody needs to be clear that they can actually operate the site in accordance with the excavation tips rules. Just a couple of things specific that have been identified in relation to the clay industry. They've been looking for your clay win contractors, your earthworks contractors. They've been specifically looking for their daily inspections and check sheets, not specifically geotechnical, but the one thing with these interventions, they do often have gone off at tangents and have wandered off into other things that wouldn't specifically be geotechnical. Proof of competence in regard to your contractors, so it's not just your own staff, but making sure that your contractors are and do have proof of their competence. And again, in regard to Regulation 39, so now obviously we're outside Part 6 of the regulations there, but again, they are looking for evidence that there is cooperation between yourselves and the contractors, and they want to see evidence of routine communication between yourselves and your contractors. So records of weekly meetings. It's not just a case of having the weekly meetings, but ensuring that they are documented. So just in summary, make sure you have all the relevant documentation in place. So specific, really, obviously, if you get 2 to 4 weeks notice that you're going to get a major hazard intervention, then there is plenty of time. But really, all that information should be to hand anyway. It shouldn't be a case of scrambling around trying to pull the information together. It should all be there. And I'll look at the geotechnical self-audit from Quinjack in a bit, and hopefully that's something that will be useful in making sure you have all the correct information. It doesn't look good if the inspector does turn up unannounced and you are then having to search high and low for particular pieces of documentation. Ensure all the documentation is consistent and aligned with each other. So across the geotechnical assessments, the quarry design and the excavation tips rules, I mean, the route for all of those should be coming from the same place anyway. So they should all be consistent, aligned, but and say they have been finding inconsistencies there. And say have them filed in an orderly fashion in a single location so you can find them to hand easily. And you're not looking rather embarrassed because you can't lay your hands on a particular appraisal or design or the geotechnical assessment. And obviously familiarity with all of those documents, the HSE inspector is obviously going to expect you to understand what it says in your geotechnical assessment, what the design says, and what it says in your excavations and tips rules. And ensure that the site operations are taking place in accordance with the excavation and tips rules, the design and the geotechnical assessment. Obviously, there's no point in having all those documents in place. They're all looking great if you're not actually able to work in accordance with those documents. So the HSE are, as part of their visit, their intervention, they are walking around the site. And they are checking all of these things. So the Quinjack Geotechnical Subcommittee, so Quinjack's tripartite association between the trade unions, the HSE and industry, for those who aren't familiar with it. And the Quinjack committee exists to provide guidance to the industry. The geotechnical subcommittee obviously is there to try and provide guidance in all things geotechnical to the industry. And the two things I just want to briefly talk about today are the geotechnical self-audit, which hopefully is a useful tool if people don't know about it, or it'd be good if there's any feedback on anybody who has used it or any companies that do use it. And also something that's been sort of on our agenda recently is in regard to selection of geotechnical specialist, and how you might go about that. So the geotechnical self-audit, again, I think it's a very useful tool. There continues to be serious geotechnical incidents within the quarrying industry, and there's been a number in the last few months and the last 12 months, and certainly in the last 5 years. And it is going to keep it on the HSE agenda for a long time. I don't think we're ever going to hear a HSE presentation that doesn't flag up that geotechnical is one of their major concerns. The guidance document that's been produced for the Quinjack Geotechnical Self-Audit leads you through the audit process. And the audit covers all the aspects likely to be required by the HSE inspector in one of their major hazard interventions. So hopefully if you've gone through the geotechnical self-audit process, then you should be good if the HSE inspector turns up on your site. So the document provides a framework to enable companies to carry out audits of their geotechnical procedures in order to check their effectiveness and identify any weaknesses or omissions in their systems. And it covers things like the management of the design process, including change, and that's something that's quite often isn't done very well within a lot of companies, is just how they manage change. Effectiveness and suitability of design documents, site inspections, training and competence of individuals, on-the-job assessment of knowledge, supervision and training, accurate and representative documentation, including notifications. So again, something that the HSE have been looking for. And it allows audit and review of the effectiveness of the control measures that have been put in place to manage the quarry safely. That can be found on the Quinjack website. It's just a nice simple form with a lot of questions and a series of tick boxes, and hopefully that will show where you may be lacking in your geotechnical management system. So one thing that the committee has been debating significantly in recent times is the selection of geotechnical specialist. So the geotechnical specialist is defined in the quarry regulations, the position of geotechnical specialist. It's one of the few, beyond the 81D, it's one of the few people actually specified in the regulations as an individual. Ultimately, it's the responsibility of the operator to ensure the competence of the geotechnical specialist that they choose. This is something that the HSE are scrutinising. I know of a particular operator who the HSE have raised questions over the geotechnical specialist that they've selected. The quarry regulations themselves, it's a fairly broad description for the geotechnical specialist, and it's quite a difficult one to manage, and that's what the Quinjack subcommittee have been sort of mulling over in recent times as to whether. So there are some people within the committee who think that we should have a national register of geotechnical specialists that quarry operators can select from, and then quarry operators will know that they've chosen somebody who is appropriate. I think there's a lot of potential logistical issues with having a register of geotechnical specialists personally. So I'm not quite sure whether it will happen or not. But ultimately, it is the operator's responsibility to ensure that they have picked a competent geotechnical specialist. The same as for any of their other people that they nominate for positions within the company. So the Quinjack guidance on selecting the geotechnical specialist, it does go a bit above and beyond the regulations, the basic requirements in the regulations. And the checklist that's in this in the guidance requires a recognised qualification in geotechnical engineering, soil mechanics or rock mechanics, and I think that needs to be appropriate to the actual type of materials that you're looking at. It's always interesting within the brick clay and tile clay side of things that we've got quite a broad range of geological conditions that we can encounter, everything from hard rock to very soft clay. So it does cover a whole plethora of geological conditions. So to actually get a geotechnical specialist who has got the full skill set for your geological conditions might not always be easy. There needs to be a chartered engineer or chartered geologist, so that's relatively straightforward, that part. Personally, I do feel that as a chartered engineer or chartered geologist, you've signed your charter to say that you will only undertake work in things that you are experienced to do. So there is a bit of policing going on within the chartered bodies. So I think that, you know, if you are getting a geotechnical specialist who's sticking their hand up to do your geotechnical assessment for you, then they are governed by their charter. 3 or more years experience relevant to the geological conditions of the site. So again, they do need to have the experience in the type of ground that is present within your quarry. Competency to perform geotechnical analysis to determine the level of hazard and risk, and that needs again to be proportionate to the type of quarry and the type of hazard and risk that there are in your quarry. And really importantly, they need to have ability to communicate their findings effectively to the operator. Geotechnical assessments need to be complicated from the point that they need to have the correct analysis in, but at the end of the day, they need to be produced in a way and communicated in a way to the operator that they can understand what it is that you're saying and what they are required to do on the back of receiving the geotechnical assessment. Geotechnical specialist must be named in the health and safety management structure. He's possibly the only person external to your business who would have to be named in the health and safety management structure. So it's important that that's done. One thing that the Quinjac Geotechnical Subcommittee doesn't really look at is, or hasn't looked at yet, but I think is something that does need to be looked at is geotechnical training. My view would be that if you are having geotechnical training provided to you, it should be being provided by a geotechnical specialist. And this is not just me as a consultant, as somebody who does geotechnical training, trying to feather my own nest, as it were. But you know, if you were having some electrical training done, you wouldn't expect it to be done by somebody else other than a qualified electrical engineer. So it is a bit of a personal bugbear of mine when I see that non-geotechnical specialists are doing geotechnical training. It is such a very important part of quarry operations. I don't really see how it can be done by somebody who isn't a geotechnical specialist, and somebody who's a geotechnical specialist who's conversant with the ground conditions in your quarry where your guys are working. On geotechnical riddles, I mean, hopefully everybody's conversant with the quarry regulations. And I'm not going to read through these, but basically there is guidance on when we should be reporting instability within quarries in the quarry regulations. And there are some important parts in there that, you know, we need to reappraise or reassess if there is a instability. So if your excavation on your site has been notified to the HSE as a significant hazard, if you have instability in there, then it does require reassessment. There's no other way around it. It's quite clear in the guidance in the regulations. And these are the sort of things that under RIDDOR would be seen as being reportable to the HSE as dangerous occurrences. So any event, including any movement or fire, which indicates that a tip is or is likely to become insecure or unsafe, and any movement or failure of a slope which has the potential to cause the death of any person or to adversely affect any building, contiguous land, transport system, footpath, public utility or service, watercourse, reservoir, or areas of public access. And I suppose this is where I was looking to try and open the debate as to at what point. I mean, that, you know, that part B covers an awful lot of things, and you know, we do regularly get falls of ground, admittedly of various different scales, within clayey quarries, and at what point do they become reportable? And guidance note 271, any movement or failure which could cause death, injury or affect adjacent property but does not actually do so because it's out of hours, so it happens at night or at the weekend, is still reportable. So when is a ground slip rockfall considered to be a RIDDOR? Because I think we could be sending reports of RIDDORs in just about every day if we just think about the scale. And this is just an example I've seen where it's a very small slip of ground. It's only a few tons of material, but it has come down. It's not a very high face. It has come down onto a haul road. And I would suggest that if we go by the strictest definition or guidance note in 270, that would be reportable. I've had conversations with the HSE. They say they will be pragmatic in it, but I just really, it was just to open it up to the floor to see whether anybody's got an opinion on RIDDORs or examples of RIDDORs or non-RIDDORs. So I don't know if there's some way of opening it up to the floor or not, Louise, or?
Yes, if everybody just unmutes themselves if they've got a question.
No. Myself and Steve Godfrey, who is on the call, we did have we ended up having a fairly heated debate for about 10 minutes on the phone the other week, just because there is a lot of difference in opinion, and whilst there is guidance in there, if we stuck strictly to the guidance, something like that, which I'm sure we see, there's a Truro Mile site, we see it on a regular basis. We just see small falls of ground, but if we stuck strictly to the guidance, we would be notifying the HSE of all of them, and they'd be getting a lot more notifications. I don't know if people feel that we could have, there could be more guidance on it.
Yeah, I think just picking up on that, Brian, as you say, we had a debate on it, and it's just, there's so many different factors in it, in the face heights, the probability, water conditions, is there liable to be people walking on the benches, therefore could be potentially at risk, and the way the contractors dug it, and all sorts of things, and how stable it is. So yeah, it's not a straightforward position.
So from an example from the hard rock quarries, in aggregate quarries, they generally have a rock trap at the bottom of their faces, and the rule of thumb in relation to RIDDOR would be, well, if it lands in the rock trap, it's not a RIDDOR. If there's no rock trap, or it comes over the rock trap, then it would be a RIDDOR. Here, obviously, we've got there isn't a sort of any kind of control measure in at the bottom of the face, but it's unlikely that would have killed somebody. If you happen to be really unfortunate and standing at the bottom of that when it occurred, you probably end up with a few broken bones. But it's just, I don't know, maybe the excavation and tips rules or the site procedures, because unfortunately a lot of clay sites you still do have to walk around. It's not really possible to get around them in a 4x4 because of the ground conditions. Maybe it's a simple one line in the excavation and tips rules to suggest that people don't walk, they wouldn't walk on the face side, they walk on the opposite side of the road, and therefore if that had come down, they wouldn't have been hit. But just something to think about, and I say it's possibly something that the Quinjack subcommittee could perhaps think about in regard to guidance. But
right.
Just something to consider about putting new rules. Harry, hi.
Hi, we had an interesting example where we have a legacy nature reserve, and the hillside moved like circa 100,000 cube, but that boundary to a housing estate, so from the backscarp of the failure to the housing estate was 30 meters. The only connection we found between that and the quarry is that we managed the water levels in there as part of our section 106 so that we could keep our extant plan permission going for our quarry. So we got in contact with the HSE and said, what do you think of this? I mean, we're going to fix the problem, but is it RIDDOR reportable? And we never got a response.
Too difficult box, that one, maybe.
Yeah. So it is intriguing. There is a lot of judgment used within the industry.
So was that site actually an active quarry at the time?
It was not, no. But due to that connection between the pumping and the maintenance of the planning permission, we decided we get in contact.
Yeah. I mean, possibly in that instance, it falls outside the quarry regulations, doesn't it? So
Yeah.
hence the lack of response from the HSE.
Yeah, we have had other issues within the quarry itself, away from the nature reserve, where we had instability within tips, and that was reported. And I think it was largely a resourcing issue that Mike Tetley was, I think, still training people up, running the show by himself,
Yeah.
and that's why we didn't have them come to site. But we put in as much detail as we could and reported that one.
Mr. Carlon.
Yeah, I was just thinking, Brian, I would agree it's probably something that we could pick up on the, you know, after our recent discussions on geotechnical specialists and that, because as you say, they're quite different conditions, and aggregates tend to be the ones that that take most of the time, but the clay quarries certainly. I think we could look into it. The specialists who were involved in clay quarries. That's something we could look at, and then obviously, you know, look at the training for the 81Cs and 81Ds. Yeah. Yep.
Well, I think my time's up. So unless anybody's got any other questions, I'll hand back to Imogen. Thank you for your time.
Thanks, Brian. Holding my breath that we don't have any more feedback issues. It sounds all right. Been using Teams for 6 years and evidently still haven't got to grips with it. So many apologies for that. That was fascinating, Brian. Really, especially resonated the bits about competency records and making sure that, you know, we're properly on top of those. And also, you know, it sounds pretty fundamental, but that the quarry design reflects the actual. You know, a lot of food for thought there. Thank you. And that brings us on to our last speaker. So we've got Rob. Thank you very much. Are we all right to bring up Rob's, Louise?
Okay, so I'm just going to be talking over the use of drones in quarries, specifically monitoring excavations and stockpiles. Okay. So the problem we have is you can have all the best surveys, you can have the fanciest designs, expensive software and tools, but if the team on the ground is not able to visualize what you've designed, it's pointless, in my opinion. So my goal of using drones is to increase the data quantity, so how much data we have, increase the resolution, so we'll be basically get data more frequently, and to make that data more accessible to everyone. So a couple of disclaimers. I'm not a surveyor. This workflow is used by surveyors. This is standard procedures for them. We can't replace them. That's not the aim of this. In fact, you'll be relying on them more because your surveyors are going to need to establish your ground control points around your site, which will make sure that any imagery and models tie in together. So stockpile building. So I'm just going to look at an idealized timeline of a clay win at one of our sites. This is going to be traditionally, so before I started using drones, how it would usually go. So you'd get your stock survey. This one was around March. At this point, you'll already have a rough timeline of when you're thinking of clay winning, but this will firm up the date for stockpile depletion and firm up that clay win start date. So once you've got the survey back, you'll draw up initial ideas, discuss options with the site, things like material sources, your blends, any major targets. So if you're putting in any major ramps, establishing tips, big objectives for the claywin. Later down the line, this will be, say, a month before your claywinning, you get this final stockpile survey just to confirm the volumes that you're going to need. This is when I would do a detailed design. By this point, we already know what we're going to do. I'll just have a month then to get together all the designs, get them all ready to send over to the site. This is claywin start. So you'll do your stockpile base prep, then you'll get it surveyed. All you guys know all of this, but just for anyone that doesn't, the design is pegged out by the contractors, surveyors, and the excavation and stockpile construction proceeds as per the design, which I produced at the end of May here. We would get minimum input other than the contractors, surveyors during the course of the claywin. You'd get a full survey done at the end of the claywin to finalise your volumes, and this will be your only opportunity to check your excavations and stockpiles ourselves. Usually by this point the contractor would have left site, so if you have problems, it's too late. They're going to have to wait till next year, or you're going to have to get them back in. So this was before I started using drones. And then these are just your standard, say, stock checks throughout the rest of the year. This window is where our drone use comes in. So this is where we get extra data throughout the claywin. We can check that we're in line with the design. We can make amendments if need be. We can sort of get a turnaround of, say, I could fly the drone, process it, come back with feedback the next day. So very fast turnaround. This is also, while the excavations are fresh, we can capture the site's geology through multiple stages. So plenty of opportunities to trace any specific strata through the quarry, and you can get measurements of them as they're moving through. It just builds up a bigger three-dimensional 3D picture of the site. This window here is where I'm going to be focusing in on. So stockpile extent and layer monitoring. I'm going to show a couple of slides now. They're going to have cross sections through the stockpiles. These cross sections were pulled from LSS, the point cloud into LSS, and then the cross sections. So start the claywin. This is before there's been any movement by the contractors. I think it's important to sort of capture the site before the stockpile prep, before you've done any base prep. It's just so that if you make sure that you're not adding material that's already on stock. So in this example, we're going to show that the ramp will be pushed into layer one. It just gives you more control of what volume in the stockpile is what. And like I said, avoids double counting any stock. So this is the target stockpile. This is pulled straight from LSS. This is the stockpile that we need to build to give us the volumes that the factory needs. And you can see on the bottom the cross section. Green is the base, and red is a cross section through the target stockpile. Just standard layer plans. Only put this to show that when I come and visit sites, they'll tell me what layer they're on. I'll refer to the layer plan and I'll figure out how high they're meant to be, and we can check if they're building it too fast, too slow. Give any feedback on how the layers are coming So this was the probably a week in ramp material used for layer 1. So you can see the ramp there. And the section down at the bottom. Down here, you can see where some of the stockpile has been pushed forward into layer 1. Second week in, they were on layer 6 at this time. You can see the stockpiles coming up slowly. This was the lower stockpile, layer 6 of 14. And again, it's an opportunity to give feedback to the contractor. Third week in, layer 12 of 14 of the lower stockpile. You see we're almost there for the target height. Okay, so week 4, lower stockpile completed with edge protection. We're now building up the piggyback stockpile. We're on layer 6, building layer 6 there. And this is a post-clay wind survey. So you can see where we are. You can see where we've had to pull the stockpile back down here to allow access. With put your stockpile back there to give us that extra volume. So there's that, the volume that was in the designed stockpile was the volume that we needed was 39,000. We've got just under 42,000. Again, that's the target stockpile. I'll just flick back and forth so you can see. It's just a short video, just to show, it's an animation, just to show the changes over time. This is using the 3D meshes that we get from processing the drone imagery. So quick before and after there. And this was in October, so you can just continue to get updates at whatever frequency you want. And it's just going to be about the same for excavation monitoring, same principle. It's going to show you an example of a ramp that we put in. So this is a new quarry ramp, which is going to be in for the remainder of the life of the quarry. So it's quite important to get right. So that's the design straight out of LSS. You can see there was a fair bit of material to move in there. We had to put in an access track around the outside to clear out a ditch in future if needed. So this is quite a way into the clay when there's not much change because the digging was happening in another area of the quarry. So they came to this towards the end. You can see this is third weekend, back to second week, third week. 4th week. See that ramp coming down. This is the final post-clay wind survey. Just do some comparisons with the design. So that's the actual survey. Here is the LSS design. And you can monitor that all the way through, just like we did with the stockpiles. So presenting data. So this is another one for just data accessibility. Anyone being able to view the data. So there's plenty of mobile mapping apps where you can export the imagery and export your designs, say your CAD designs or GIS, however you export them. You can load them straight to a mobile mapping app, and you can send that to the quarry managers and they can walk along it just like they're walking on Google Maps. And anything that you want to draw on CAD or GIS, you can export so they can walk over any feature that you draw. This is the platform that we use for viewing the 3D models, and this is just to show that you don't need any software for this. I can share this as just a web link. You can see above and below. These are some of the comparisons. You pull this slider left to right, and you can do exactly what I showed you beforehand, but you can do that on a mobile phone. You can send this to anyone. Some more examples of the ramp. Again, the ramp from another angle. Okay, so this is the sort of the final section here. It's about keeping a record of our sites. So, as you know, because of the faces and clay quarries, they weather so quickly, and they grow vegetation pretty quick relative to hard rock, and a lot of them are landfilled. So it's quite a small window for us to document the geology in these clay quarries. When you're getting your surveys by drone, they'll capture the whole site. They'll capture features which you are or not aware of. So if you find a feature in the future, you come back at your surveys, you can look at it, and you can analyze the change over time. So, for example, if you've got areas of instability, they'll often show well before failure. So you can look back through your imagery and you can see slow movement over time, which you would not have noticed or may not have noticed just going out and seeing the quarry with your own eyes. You can see these are longer term trends by using this imagery. So here's some examples of, well, this is showing the importance of capturing the faces when they're freshly excavated. So here's an image from 2016 of a fault, and in the 2025 models, they're not visible. You can see it's vegetated up, especially quick there, probably because of the fault itself and the water flow. There's another example, 2016 image of a fault. You can see gypsum contaminated mudstone to the right. This has been captured in the model here, but not to amazing quality. But it's just to go to show that it will capture things even if you don't know they're there at the time. So. A perfect example of capturing the geology and the quarry development is this Hales-Owen Etruria Formation unconformity. So this has been well documented at one of our sites. You see this here. This is our Stocken Area extension. So I'll just flick back and forth. See, there is the unconformity. There's a 8 meter vertical difference between this contact high here and this sort of eroded channel feature down at the bottom there. Okay. And this is just another video showing this contact, this unconformity. You can see you follow this white line here, that's a marker for it. And follow it all along. So in summary, in my opinion, the data that we get from drones is underutilized. So from the ortho photos, the 3D meshes, which a lot of the animations, or all the animations I've showed you today are produced from, and the point clouds, which are put into LSS. The data that all the data we have should be more accessible. We should be working to make it more accessible within our teams. Anyone should be able to view the surveys and the data that we have. People with specific softwares and tools shouldn't have a monopoly on viewing the quarry data. We can and should use the correct permanent record of the geology. Yeah, so the level of detail that you want on these models depends on how long you want to spend. So there are apps on your phone where you can do the same thing for, say, hand specimens. You know, just a different scale. It's the same principle, but just at a different scale. Yeah. Okay. That's that. Any questions?
Thanks, Rob. Fascinating to see how we can effectively. Oh no, there is a question. Go on, I jumped in. Go on, Tim.
Rob, hi. We have met over at your digs at Kingsbury. Just curious to what kit you use for this. We run image capturing drones alone, but have you got something more advanced? You must be picking up topography from this.
Most of the ones that I showed you were just from a DJI Mini 2, just a little 250 gram drone. So you don't have to have fancy equipment for it. It's just taking photos at the end of the day.
But your sort of alignment with the topography as the stockpile is progressing,
yeah,
sort of seems to intimate that you are seeing levels, but presumably you're not from the imagery.
Yeah, so that's when the surveyors will come in. So you work alongside your surveyors. They will put permanent ground control out along the site, so I can just tie into that. So when you get a survey, usually they'll come in and mark ground control points, like known points around the site. If you just ask your surveyor, go and set up some permanent markers for me that I can use. So
Understood.
you can go to a site and basically do a survey whenever you want. You don't have to wait for, say, the surveyors can't come out for 2 weeks.
Yeah. Thank you.
Hi, it's John Carlin. Can you just explain to me how you do that then? Because I can understand that's how surveyors do it. Is they set a control point, then they'll have a drone, and they can tie everything in. But you're saying that's a relatively, what you're using is a relatively cheaper alternative, just for you to be able to monitor the site. So how do you tie it into your ground control then?
So it's the exact same principle. It's the exact same workflow that the surveyors will do. So
All right.
you just take all them images and you put them into photogrammetry software. So there's
Right.
various ones. Yeah, so exact same workflow as then, really.
So your drone relates to the control points, and then you can use that in the photogrammetry software that you've got.
Yeah. So the drone flies, take photos, it captures all them ground control points. I'll input them ground control points into the software to sort of georeference it exactly how the surveyors would. The only difference is I'm not making my own ground control points like the surveyors do. I'm using the ones that they've put out for me.
They have to do that. Yeah, follow that. Okay,
and then we get the ground control points updated as often as they come in. So we obviously if you have some in the quarry degrades and they might move. So it's important to just keep on top of them, keep them updated every time the surveyors come in.
Yeah, I understand that. Okay. Yep. Thanks.
No last minute questions? Okay, thanks, Rob. That was really fascinating to see how we can effectively use technology to minimise the risk, and also how the stockpile changes throughout the duration of the build. Thank you so much to all three speakers. I hope everyone agrees that they were all really interesting, engaging sessions. I'm sure if there's any questions after the event, that Andy, Brian and Rob would be more than willing to answer them. So with that, we'll move on to the awards. And it is my pleasure to present the first two awards, recognising exceptional achievement in clay studies at the University of Derby. These honours reflect not only academic excellence, but also a commitment to furthering the individual's knowledge while working full-time. Our first award celebrates the highest grade achieved in the Diploma in Clay Studies. This year's recipient, Steve Martin of Ibstock PLC, has demonstrated outstanding dedication, passion and drive throughout his studies. Please can you join me in congratulating Steve Martin, who receives a well-deserved prize of £200. As an aside, I mean, doing this online, it feels a little bit more stilted. Apologies. So our second award recognises the highest mark in the foundation degree in clay technology. This distinction goes to Ian Pillsbury, whose impressive achievements highlight both his technical knowledge and his enthusiasm for continuous learning. Ian, massive congratulations. He's sitting opposite me, and on earning another £200. We'll move on to the next award, which will be presented by Chris Hunnest. I'll move up.
All right.
Sit there here.
Thank you.
So technological here.
Firstly, before I start on the presentation of the Keith F.R. Morton Award, I would like to say thank you to the teams that have been involved in revising the teaching materials in the last 12 months. Having been involved in this in the past, I do realise what a huge commitment it is and essential that we keep the teaching materials up to date and current. So thank you everybody that has been involved in that. The Keith Morton Award, under Keith, in Keith's words, to be awarded annually as determined to an individual who best exemplifies the exceptional education and training achievement in clay technology via the various courses that are run through HCTA and the Trust. The UK industry is fortunate indeed to be populated by many dedicated men, women, whose commitment and contribution to a demanding continuous process industry is extraordinary and seldom routine. But some of them also to strive and learn and improve their knowledge whilst working in a demanding role is equally as commendable. It is hoped that this award can now recognise a few of them. And this year's winner is Ian Pillsbury again. So
you've got to come round this time.
As we've done in the past, Ian is like to keep this for 12 months and look after it. He also receives a small bottle deal and a cheque for £500. So I think the drinks are only in today. Thank you.
Right, got me back now. So the final award that I'm going to present today is the Ernest Simpson Award and the Lisney Prize. The award was first created in 1982 by the ICT to recognise members who have given meritorious service to the heavy clay industry, those whose dedication, expertise and commitment have had a meaningful and lasting impact. The award takes its name from Ernest Simpson, the managing director of the Berry Hill Brick Company and a long-standing supporter of the ICT. He was one of the 60 individuals present at the very first AGM back in 1927 and went on to found the ICT North Staffordshire branch, which he continued to support well into his 90s. In 1992, the award was further elevated with the introduction of the Lisney Prize, a £500 cheque donated annually, now by Forterra, honouring the Lisney family who founded the Red Bank Manufacturing Company in 1919. Their wish was that the trophy should carry not only recognition, but also a tangible acknowledgement of an outstanding contribution. Over the past year, the award winner has undertaken an immense piece of work for the University of Derby's Clay Diploma and Foundation programmes on behalf of the HCTA. In 2024, they carried out a comprehensive review of 5 modules within the Clay Evaluation module, painstakingly updating, rewriting and refreshing the content to ensure it remains both current and relevant for the next generation entering our industry. This was not a quick or simple task. It required a substantial number of hours, deep technical knowledge and meticulous attention to detail. They delivered this work to an exceptionally high standard and, importantly, on top of their full-time job. Their commitment has materially strengthened the quality and consistency of clay education across the sector. Before joining Ibstock, they completed a BSc Honours in Geology at the University of Birmingham, producing a final year project on the geology of Capel Curig in Snowdonia. They're sitting opposite me. Alongside their studies, they worked at the Leicester Royal Infirmary as a biomedical assistant, gaining experience in forensic toxicology and laboratory analysis, skills that would serve them well in the years to come, or the laboratory analysis bit anyway. The award winner joined Ibstock in 2018 as a laboratory technician, following the traditional pathway familiar to many in this room. Working hands-on with raw materials and file products gave them a solid foundation in the ceramic process. Just 1 year later, they became an assistant geologist, taking on interpretation of geological and ceramic data and rapidly building the expertise required in this demanding field. By October 2022 and following, the words that were given to me were super epic performance. They were promoted to geologist, where they now lead many geological projects across the company. Their professionalism, technical capability and good humour have made them an invaluable colleague and a respected contributor to our wider industry. For her outstanding service, her dedication to the advancement of clay education and her continuing commitment to the future of our sector, it's my honour to present the Ernest Simpson Award and the Lisney Prize to Daisy Mulungani. Thanks.
Come round.
This is yours. Thank you. Really well deserved.
Thank you everyone.
Never had a trophy. Well, you get a big one now.
And
Oh, thank you. And also a chair.
a check.
I don't know what to say. Thank you. I think you have a lot to do. Brings us to the end of the Heavy Clay online events. Yeah, as I said before, thank you to everyone for attending. It's really, really appreciated. And we'll be back next year, hopefully for an in-person event. Thank you very much. Bye.
Thank you very much.